Dear students, welcome to chemistry classes. So today we are going to discuss about electrolytic cell and electrolysis. Okay. So ಇವತ್ತು ನಾವು ಏನು ಮಾಡೋಣ ಅಂತಂದ್ರೆ electrolytic cell ಮತ್ತು electrolysis ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. So before that, in the previous video also we have discussed about in very starting we have discussed about electrolytic cell, isn't it? And the electrolysis. And now we know that what is electrolytic cell and what is electrolysis. So how we can define electrolytic cell? So I have a trick. I told you a trick to remember electrolytic cell. So electrolytic cell, a device which converts electrical energy into chemical energy, isn't it? So like this we can remember. So this is a device which converts electrical energy into chemical energy. Means in this cell, electrolytic cell, the reaction taking place is a non-spontaneous chemical reaction which cannot take place on its own. To make that chemical reaction to occur, we have to supply external energy in the form of electric current, isn't it? So in this cell, non-spontaneous chemical reaction takes place. For the non-spontaneous chemical reaction, delta G is always positive, please remember. And the process taking place in this cell is called as electrolysis. So please remember, the process which is taking place in the electrolytic cell is called as electrolysis. And now we are going to deal with, so what is the importance, what is the use of electrolysis? Okay, so you might be remembered about that, you might be saw that there are some rolled gold chains. Do you remember, or do you know that rolled gold chains? On this to chain ornaments, they look like gold but they are not gold. They look like gold but they are not exactly gold. So ಗೋಲ್ಡ್ ತರ ಕಾಣಿಸ್ತಾ ಇರ್ತವೆ ಬಟ್ ಗೋಲ್ಡ್ ಇರೋದಿಲ್ಲ. ಆ ಥರ ಕೇಳಿದ್ರೆ ಆರ್ನಮೆಂಟ್, ಅವೆಲ್ಲ ಆರ್ನಮೆಂಟ್ ಹೆಂಗೆ ರೆಡಿ ಮಾಡ್ತಾರೆ ಅಂತಂದ್ರೆ ದೋಸ್ ಆರ್ ಪ್ರಿಪೇರ್ಡ್ ಬೈ ದಿ ಪ್ರೊಸೆಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರೋಪ್ಲೇಟಿಂಗ್. ಅವ್ಕೆ ಹೆಂಗೆ ಅವುಗಳನ್ನ ಇದನ್ನ ಮಾಡ್ತಾರೆ ಅಂತಂದ್ರೆ ಎಲೆಕ್ಟ್ರೋಪ್ಲೇಟಿಂಗ್ ಮಾಡಿ ಏನು ಮಾಡ್ತಾರೆ, ಅವುಗಳನ್ನ ರೆಡಿ ಮಾಡ್ತಾರೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಹೆಂಗಂತಂದ್ರೆ, ಈಗ ನನಗೆ ಏನು ಬೇಕಂತಂದ್ರೆ ಐ ಹ್ಯಾವ್ ದಿಸ್ ಬ್ರೆಸ್ಲೆಟ್ ಅಂತ. ಸೊ ಈಗ ನನ್ನ ಕಡೆ ಒಂದು ಬ್ರೆಸ್ಲೆಟ್ ಇದೆ. ಈ ಬ್ರೆಸ್ಲೆಟ್ ಏನು ಮಾಡ್ಬೇಕಂದ್ರೆ ಇಟ್ ಈಸ್ ಮೇಡ್ ಆಫ್ ಸಮ್ ಮೆಟಲ್, ಯಾವುದೊಂದು ಮೆಟಲ್ನ ಮಾಡಿದ್ದಾರೆ. But I want to convert this bracelet into gold. So I cannot convert this metal into gold. But ಏನು ಮಾಡ್ಬೋದು, ನಾ ಇದ್ರ ಮೇಲೆ ಗೋಲ್ಡ್ ಪ್ಲೇಟಿಂಗ್ ಮಾಡಬಹುದಾ? ಗೋಲ್ಡ್ ಪ್ಲೇಟಿಂಗ್ ಮಾಡಬಹುದು. ಸೊ ಗೋಲ್ಡ್ ಪ್ಲೇಟಿಂಗ್ ಹೆಂಗೆ ಮಾಡ್ಬೋದು, ನಾವು ಆ ಗೋಲ್ಡನ್ ಲಿಕ್ವಿಫೈ ಗೋಲ್ಡನ್ನ ಮೆಲ್ಟ್ ಮಾಡಿದ್ರ ಮೇಲೆ ಏನಾರ ನಾವು ಪೇಸ್ಟ್ ಮಾಡಿದ್ವಿ ಅಂತಂದ್ರೆ ದ ಸಮ್ ಪಾರ್ಟ್ ಆಫ್ ದಿ ಮೆಟಲ್ಸ್ ಆರ್ ಪ್ಲೇಟೆಡ್ ವಿತ್ ಗೋಲ್ಡ್ ಬಟ್ ನಾಟ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಆಲ್ ದ ಸರ್ಫೇಸ್ ಆರ್ ಆಲ್ ದಿ ಪಾರ್ಟ್ ಆಫ್ ದಿ ಮೆಟಲ್ ಕೆನ್ ನಾಟ್ ಬಿ coated by the gold. For that purpose we use electrolysis. ಅವಾಗ ಏನು ಮಾಡ್ತೀವಿ, ನಾವು electrolysis ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಸೊ electrolysis ಯಾವ ತರ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅಂತಂದ್ರೆ, will take a beaker, in that beaker will take gold. ಸೊ ಒಂದು ಎಲೆಕ್ಟ್ರೋಡ್ ಅಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ, ನಾವು ಗೋಲ್ಡ್ ನ ಇಡ್ತೀವಿ. ಸೊ ಇಫ್ ಐ ಟೇಕ್ ದಿಸ್ ಇಸ್ ಗೋಲ್ಡ್, ಒಂದು ಎಲೆಕ್ಟ್ರೋಡ್ ಗೋಲ್ಡ್ ಇತ್ತು ಅಂತಂದ್ರೆ ಇನ್ನೊಂದು ಎಲೆಕ್ಟ್ರೋಡ್ ಯಾವ ತಗೋಬೇಕು, ಯಾವ ಮೆಟಲ್ ಮಾಡಿ ನಾವು ಆ ಎಲೆಕ್ಟ್ರೋಪ್ಲೇಟಿಂಗ್ ಮಾಡಬೇಕಲ್ಲ ಅದನ್ನ ಏನು ಮಾಡ್ತೀವಿ, ಇನ್ನೊಂದು ಎಲೆಕ್ಟ್ರೋಡ್ ಅಂತ ತಗೋತೀವಿ. ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ, in the process of this electrolysis, the atoms from one metal, the atoms from one electrode move in the form of into the solution as ions. So those ions are deposited on another electrode, isn't it? So we know about that. So now ಇಲ್ಲಿ ಈ ಎಲೆಕ್ಟ್ರೋಲೈಸಿಸ್ ರಿಯಾಕ್ಷನ್ ಆಗಬೇಕಾದ್ರೆ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ, ಒಂದು ಎಲೆಕ್ಟ್ರೋಡ್ ದಾಗಿದ್ದಂತ ಅಟಮ್ಗಳು ಅಯಾನಿಗೆ ಬರ್ತವೆ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ಒಂದು ಎಲೆಕ್ಟ್ರೋಡ್ ಅಲ್ಲಿ ಇರುವಂತ ಅಟಮ್ಗಳು ಸೊಲ್ಯೂಷನ್ ಗೆ ಬರ್ತವೆ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ಅಯಾನ್ಸ್. ದೋಸ್ ಅಯಾನ್ಸ್ ಆರ್ ಡೆಪಾಸಿಟೆಡ್ ಆನ್ ಅನದರ್ ಎಲೆಕ್ಟ್ರೋಡ್. ಆ ಅಯಾನ್ಗಳು ಏನು ಮಾಡ್ತವೆ, ಇನ್ನೊಂದು ಎಲೆಕ್ಟ್ರೋಡ್ ಮೇಲೆ ಡೆಪಾಸಿಟ್ ಆಗ್ತವೆ, ಹೌದಾ? ಸೊ ಹಾಗಾದ್ರೆ ಏನ್ ಮಾಡ್ಬೋದು, ನಾವು ಇಲ್ಲಿ ಗೋಲ್ಡ್ ತಗೊಂಡಿವಿ ಅಂತಂದ್ರೆ ಈ ಗೋಲ್ಡ್ ಏನಾಗುತ್ತೆ, ನಮಗೆ ಲಿಕ್ವಿಡ್ ಫಾರ್ಮ್ ಆಗಿ ಬರುತ್ತೆ. ಯಾವ ತರ, ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ಅಯಾನ್ಸ್. ದೋಸ್ ಅಯಾನ್ಸ್ ಆರ್ ಪ್ಲೇಟೆಡ್ ಆನ್ ದಿಸ್ ಎಲೆಕ್ಟ್ರೋಡ್. ಓಕೆ, ಸೊ ಆ ತರ ಏನ್ ಮಾಡ್ಬೋದು, ನಾವು ಎಲೆಕ್ಟ್ರೋಪ್ಲೇಟಿಂಗ್ ಅನ್ನ ಮಾಡಬಹುದು. ಸೋ ಮೆನಿ ಮೆಟಲ್ಸ್ ಆರ್ ಎಲೆಕ್ಟ್ರೋಪ್ಲೇಟೆಡ್ ಬೈ ಯೂಸಿಂಗ್ ಎಲೆಕ್ಟ್ರೋಲೈಸಿಸ್. ಅರ್ಥ ಆಯ್ತಾ? And also it is most important. Why it is most important? So ಯಾಕೆ most important ಅಂತ ಈಗ ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಓಕೆ, ಸೊ now come to the point. These electrolytic cells are more important in laboratory process. In our laboratory process they are also more important, as well as they are also important in chemical industry. To prepare some chemicals we should go for electrolysis. There are some chemicals which cannot be prepared by other methods. They can be best and economically and conveniently prepared by electrolysis process. So for them we should use electrolysis. Okay. So here we have discussed about the simplest electrolytic cell. Here one of the simplest electrolytic cell is consist of two copper strips as copper electrode. Here this is my electrolytic cell. So in this electrolytic cell I have taken two copper electrodes. I have taken two simple copper strips as copper electrodes. These two are externally connected with a key and battery. So this is current source. That battery is nothing but current source. And here I have kept copper sulfate solution. These two copper electrodes are dipped in copper sulfate solution. So the electrode which is attached with positive terminal of the battery is called as anode, and the electrode attached with negative terminal is called as cathode. But actually we should define cathode and anode on the basis of what? Not on the basis of their signs, but we have to define them on the basis of chemical reaction. The electrode at which oxidation takes place is called as anode, and the electrode at which the reduction takes place is called as cathode. So by convention you should understand anode means oxidation, cathode means reduction. So fix in your mind. These two copper strips are dipped in the very same solution, copper sulfate solution. And do you remember, in electrolytic cell we use only one beaker, but for galvanic cell we use two beakers. Two half cells are taken. Here the cell is made by a single beaker. The container is same for both the electrodes. If DC current or DC voltage is applied, here DC voltage is applied to the electrodes, to these two electrodes, then what happens? If current is passed through the circuit, what will happen? Here the solution contains Cu2 plus ions. We have to focus only on Cu2 plus ion, and we don't have any business with SO4 2 minus ions, isn't it? Copper 2 plus ions are there in the solution. On passing electric current, when as soon as key is switched on, the switch is turned on, what will happen? Here the Cu2 plus ions from the solution go into this electrode, isn't it? And from this electrode they will receive electrons. Here at cathode the Cu2 plus ions are discharged by getting electrons from the cathode. Then the Cu2 plus discharge at cathode as follows. How they are discharged? The Cu2 plus ion from the solution go into the cathode, and they will receive two electrons from the cathode, and they are reduced as copper atoms, and they are deposited on the surface of the electrode, isn't it? They are deposited on the surface of electrode, and in some rare cases they are also settled at the bottom. The sum of the copper atoms are settled at the bottom. Okay. Next, what happens? The process taking place at this electrode can be written like this: at cathode Cu2 plus 2 electron gives copper. And what about at anode? What happens to anode? Here at anode, here this reaction is called as reduction, isn't it? This is reduction. If reduction takes place at cathode, then what about anode? Here it must be oxidation. Here it should take place oxidation. The oxidation reaction takes place at the anode. Here at anode, what happens? The atoms from the surface of electrode, they are converted. The atoms from the surface of electrode, they are converted into copper ion. The copper atoms from the electrode surface, they come into the solution as ions by losing their electrons. So those electrons left on the electrode go through the circuit and they come like this, isn't it? So the copper atoms are converted into copper ions and they go into the solution. Means here the cyclic process takes place. Copper atoms are converted into copper ions, and these copper ions are deposited on the copper electrode. So now as time lapses, what happens? This electrode goes on dissolving, isn't it? Because the number of atoms are converting into ions. So this electrode goes on dissolving. The mass of the electrode goes on decreasing. This electrode dissolves, and ultimately the mass of this electrode increases, because here the copper atoms are deposited on this electrode, isn't it? So according to this equation, copper gives out 2 electrons and it is converted into copper 2 plus ions, and 2 electrons are given. Those electrons are moved in this direction and they will reach the cathode, and here they are reduced. See here, by the process of this electrolysis, the copper is purified. So this is very much important industrial process. So why? Because the impure copper is purified by using this process. Here impure copper, how it is purified? So initially I have to take this electrode, copper electrode, a thin metal strip, pure copper metal strip, add as a cathode. It must be very thin. Here I will take very thin copper electrode as cathode. Here I have to take the impure copper, the copper which is to be purified, I have to take at anode. At anode I have to take impure copper, at cathode I have to take pure copper. So now as soon as the battery is switched on, what happens? Only the copper atoms from the electrode are converted into copper 2 plus, isn't it? And the other metals which are present in the solution, which are present on the surface of copper, this surface of the impure copper, they come into the solution. They also come into the solution. Here now the solution contains copper 2 plus ions and some impure ions given by the copper, impure copper. Now here at cathode what happens? Only Cu2 plus ions are reduced and they are deposited over the surface of cathode. And while doing this process, the sum of the impure atoms which are deposited at the bottom of the anode. So this is called as anode mud. It is called as anode mud. Here. So this is very important industrial process by which copper can be purified, isn't it? So now not only copper, so many metals are purified by this method, and also the many active metals. What do you mean by active metals? The metals which are more reactive, they are called as active metals. Example: sodium, potassium, magnesium. Why? Because if sodium is kept on open air, what will happen? What will happen? So if you keep the sodium on open air, there will be boom, there will be blast, it will blast. Okay, so here those are called as active metals. So the active metals like sodium, potassium, magnesium, aluminium, those can be prepared by only this method. They cannot be prepared by a normal or the classical processes, isn't it? The many active metals like sodium, magnesium, aluminium, etc. are produced on large scale, means industrially, large scale by electrochemical reduction of their ions. So this can be prepared by only the electrochemical reduction of their cations. Here also this is the same. The cations are electrochemically reduced, which cannot be reduced by using chemical reducing agents. Here to prepare element or a metal, to prepare a metal, to purify metal, so we should go for metallurgy. I think you must be aware about metallurgy. So in that metallurgy, what we do, we use chemical reducing agents like coke or carbon monoxide, carbon dioxide to reduce some metals like iron, chromium, cobalt, nickel. To reduce them, we use coke, carbon monoxide or carbon dioxide as reducing agent. But these metals, the sodium, magnesium, aluminium, they can never be reduced by using those reducing agents, classical reducing agents. So because of that reason, to reduce them, we should use this method, isn't it? So this can be prepared by electrochemical reduction of their cations. Here ನೋಡಿಲ್ಲಿ ಈ ಸೋಡಿಯಂ, ಮ್ಯಾಗ್ನೀಷಿಯಂ, ಅಲ್ಯೂಮಿನಿಯಂ ಇವೆಲ್ಲ ಇದಾವಲ್ಲ, ಏನು ಕರಿತೀವಿ ಅಂದ್ರೆ ನಾವು ಆಕ್ಟಿವ್ ಮೆಟಲ್ ಅಂತ ಕರಿತೀವಿ. ಯಾಕೆ ಆಕ್ಟಿವ್ ಮೆಟಲ್ ಅಂತ ಕರಿತೀವಿ ಅಂತಂದ್ರೆ ಇವು ನಾರ್ಮಲ್ ಟೆಂಪರೇಚರ್ ಒಳಗ ಅಥವಾ ರೂಮ್ ಟೆಂಪರೇಚರ್ ಒಳಗೆ ಏನು ಮಾಡ್ತಾವ ಅಂತಂದ್ರೆ ದೇ ಶೋ ಹೈ ರಿಯಾಕ್ಟಿವಿಟಿ ಏನಿರೋದು ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಸೊ ಅದ್ರಾಗ ಏನು ಕರಿತೀವಿ ನಾವು ಆಕ್ಟಿವ್ ಮೆಟಲ್ ಅಂತ ಕರಿತೀವಿ. ಇವುಗಳನ್ನ ನಾವು ಕ್ಲಾಸಿಕಲ್ ಮೆಥಡ್ಗಳನ್ನ ಯೂಸ್ ಮಾಡಿ, ನಾವೇನು ಹಳೆ ಸಂಪ್ರದಾಯದ ಪ್ರಕಾರ ಏನು ಯೂಸ್ ಮಾಡ್ತೀವಲ್ಲ ಮೆಟಲ್ಗಳನ್ನ ರೆಡಿ ಮಾಡಬೇಕಾದ್ರೆ ನಾವು ಕೋಕ್, ಕಾರ್ಬನ್ ಮೊನಾಕ್ಸೈಡ್, ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಅಂತ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ ಯೂಸ್ ಮಾಡ್ತೀವಲ್ಲ, ಆ ಥರ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ಗಳನ್ನ ಇದನ್ನು ಯೂಸ್ ಮಾಡಿ ನಾವು ಸೋಡಿಯಂ, ಮ್ಯಾಗ್ನೀಷಿಯಂ, ಅಲ್ಯೂಮಿನಿಯಂ ರೆಡಿ ಮಾಡೋಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ. ಪ್ರಿಪೇರ್ ಮಾಡಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ. ಸೊ ಅದಕ್ಕಾಗಿ ಏನು ಮಾಡಬೇಕಂದ್ರೆ ಈ ಸೋಡಿಯಂ ಮ್ಯಾಗ್ನೀಷಿಯಂ ಅಲ್ಯೂಮಿನಿಯಂ ರೆಡಿ ಮಾಡಬೇಕಾಯಿತು ಅಂತಂದ್ರೆ ಸೊ ನಾವು ಏನು ಮಾಡಬೇಕು, ವಿ ಶುಡ್ ಗೋ ಫಾರ್ electrochemical process. So that is none other than electrolytic process. Okay. ಸೊ ಇಲ್ಲಿ ಯಾವ ತರ ಮಾಡ್ತೀವಿ ಅಂತಂದ್ರೆ ಸೋಡಿಯಂ ಅಂಡ್ ಮ್ಯಾಗ್ನೀಷಿಯಂ ಆರ್ ಪ್ರಿಪೇರ್ಡ್ ಬೈ ದೇರ್ ರೆಸ್ಪೆಕ್ಟಿವ್ ಕ್ಲೋರೈಡ್ ಸೊಲ್ಯೂಷನ್, ಫ್ಯೂಸ್ಡ್ ಕ್ಲೋರೈಡ್ ಸೊಲ್ಯೂಷನ್. ನಾನು ಸೋಡಿಯಂ ರೆಡಿ ಮಾಡಬೇಕಾಗಿತ್ತು ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ಯಾವ ಸೊಲ್ಯೂಷನ್ ತಗೋಬೇಕು ನಾನು, ಐ ಶುಡ್ ಟೇಕ್ ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್ ಸೊಲ್ಯೂಷನ್. ಟು ಪ್ರಿಪೇರ್ ಸೋಡಿಯಂ ಐ ಶುಡ್ ಯೂಸ್ ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್ ಸೊಲ್ಯೂಷನ್. ಟು ಪ್ರಿಪೇರ್ ಮ್ಯಾಗ್ನೀಷಿಯಂ what should I use, magnesium chloride solution, MgCl2 solution. ಇಲ್ಲಿ ಕಾಪರ್ ರೆಡಿ ಮಾಡಬೇಕಾದ್ರೆ ನಾನು ಕಾಪರ್ ಸಲ್ಫೇಟ್ ತಗೊಂಡಿದ್ದೀನಿ. ಸೋಡಿಯಂ ರೆಡಿ ಮಾಡಬೇಕಾಗಿತ್ತು ಅಂತಂದ್ರೆ ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್, ಮ್ಯಾಗ್ನೀಷಿಯಂ ಬೇಕಾಗಿತ್ತು ಅಂದ್ರೆ ಮ್ಯಾಗ್ನೀಷಿಯಂ ಕ್ಲೋರೈಡ್ ಸೊಲ್ಯೂಷನ್ ತಗೋಬಹುದು. So sodium and magnesium are produced by the electrolysis of their fused chlorides. Okay, and aluminum is produced by its oxide. So aluminum ಏನು ಮಾಡ್ತೀವಿ ಅಂತಂದ್ರೆ we cannot prepare aluminum by aluminum chloride, isn't it? So aluminum chloride is a Lewis acid. It will show some other reactivity. Aluminum prepare ಮಾಡಬೇಕಾದ್ರೆ ಏನು ಯೂಸ್ ಮಾಡ್ತೀವಿ ನಾವು, we use aluminum oxide. It is also called as alumina. You might remember, we have heard about this. Al2O3 is also called as alumina. So aluminum is prepared by alumina. Alumina ದಿಂದ ಏನು ಮಾಡ್ತೀವಿ ನಾವು, aluminum ಅನ್ನ ಪ್ರಿಪೇರ್ ಮಾಡ್ತೀವಿ. ಹೌದಾ? In the presence of cryolite, to prepare aluminum by alumina we should use cryolite. ಈ cryolite ಅಂತ ಒಂದು ಕಾಂಪೋನೆಂಟ್ ಅನ್ನು ಯೂಸ್ ಮಾಡ್ತೀವಿ. Cryolite means Na3Al6. So the conducting agent ಅಂತ ವರ್ಕ್ ಮಾಡುತ್ತದೆ. It behaves as conducting agent. So Na3Al6 cryolite, ಈ cryolite ಅನ್ನು ಯೂಸ್ ಮಾಡಿ ಮಾಡಬಹುದು ನಾವು ಅಲ್ಯೂಮಿನಿಯಂ ಪ್ರಿಪೇರ್ ಮಾಡಬಹುದು. So we are going to learn about this thing very much deeply in topic number 6, isolation of elements, isn't it? So ಆ ಟಾಪಿಕ್ ಅಲ್ಲಿ ನಾವು ಇದರ ಬಗ್ಗೆ ಏನು ಮಾಡ್ತೀವಿ, ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ. So particularly the process of preparation of aluminum from alumina by using cryolite is called as Hall-Héroult process of preparation of aluminum. That is most important process for your board examination. Each and every year or alternate years it is definitely asked for 3 marks. Okay, so this is about the electrolytic cells and electrolysis. Okay, I hope this video is helpful for you. Please like, share and comment and share among your friends, and please don't forget to subscribe. Okay, thank you.